Alright, in this Algebra 1 video, Chapter 2, we're going to actually do two sections at once because these are some skills we talked a lot about last year in the 7th grade. We're going to talk about Lesson 2, solving one-step equations, and we're also going to talk about Lesson 3, solving multi-step equations. Now, our objective is, as the student, I can solve equations with any operation because I will apply the properties of equality and I will work backwards. And when I say work backwards, I'm referring to using the order of operations in reverse. So a lot of this should sound familiar. Some of it will be different towards the end, so make sure you stick through and you check out all of it. Some of it will be new. Alright, so speaking of solving equations, brief vocabulary moment. Remember, to solve an equation means essentially you're going to figure out what value of the variable, so in these examples, what value for this variable will make it a true statement. And we know by doing that, you solve equations by isolating the letter, getting the variable by itself, and moving everything to the other side. So these examples, you probably already know how to do most of them. We're going to show how each of them, we're going to use our properties of equality. So for example, many of you guys already know, if you're going to solve, in this first example, in this first one, if we're going to solve for C, we've got to get rid of plus 9. Well, in order to get rid of plus 9, we have to do the inverse operation, or the opposite operation, or whatever will undo it. And that means subtract 9 from both sides. They then cancel on the left side, so then on the left side, we're left with C equals, now on the right side, 4 minus 9, that's negative 5. So I know that is one that we've been doing for 2 years now, and I know, especially my students from last year, this should sound familiar, how to solve for this, how to solve for C, and that's okay. But here's what I want to point out to you. That's good you know that, how to do that, but this stage right here, when we subtracted 9 to both sides, if in order to defend yourself, in order to justify it, just like what we were doing in Chapter 1, we were naming those properties, we are allowed to do what we just did, and we talked about this in 7th grade, because we subtracted, it's a subtraction property of equality. That's how we're allowed to do what we did. And essentially it's what we talked about. You can do whatever you want to an equation as long as you do it to both sides. Now, just for the sake of proving that you know what you're doing, go ahead and just quickly solve each of these real fast and show your work when you do it. And I'm going to press pause and I'm going to do the same thing. And the only one that I think you might have a little bit difficulty with, if you don't remember, is the one on the bottom right, the 3/4 times k equals 9. But I'll give each of those a shot, and I'll briefly explain each of them. But hit pause. So the one that I did in blue, we had e minus 12 equals 5. You got to get rid of minus 12 by adding 12 to both sides. You're allowed to do that because of the addition property of equality. So that's a vocabulary word concept you want to know. So we got e by itself, and we're left with e equals 17. The next one, x divided by 9. You get rid of divided by 9 by timesing by 9. Multiply both sides by 9, gets the multiplication property of equality. And we were left with x equals 36. Now try the other two if you haven't done so already. Okay, our example in the bottom center, to get rid of times negative 3, we divide both sides by negative 3. And by the way, that's how you get rid of any coefficient. You always do it by dividing. So when you do that, you're left with x equals negative 4 because 12 divided by negative 3 is negative 4. And we're allowed to do that because of the division property of equality. So essentially every single operation, add, subtract, multiply, divide, each of them has their own property of equality. And that just means you did the same thing to both sides of the equal sign. That's what matters. It's all about the equal sign. Now, take a look at the example on the bottom right. It's a coefficient still, even though it's a fraction. This is solving with rational coefficients. And if this one gives you, how I'm explaining it briefly here is a little confusing for you, I've got at least one, possibly two videos. Go through the YouTube channel, the 7th grade sections. There are other videos on solving with rational coefficients if you need more time to understand this one. It's a coefficient. We get rid of all coefficients by dividing. So divide both sides by 3/4. Notice in the last example I used a fraction bar for the division, and this one I used the division sign. It's up to you which one you use, just to help make sure it's clear for you. Okay, so we're left with k on the left side. And on the right side, we just need to remember how to do 9 divided by 3/4. Dividing by a fraction, you multiply by the reciprocal. So the division becomes a multiplying, and 3/4 gets flipped, so it becomes 4 over 3. Now you have 9 over 1 times 4 over 3. Find out what that equals. Feel free to use a shortcut if you know it, but you don't have to. I'm not going to use it here, and then just solve from there. Multiplying straight across, we have 9 times 4 is 36. On the bottom, 1 times 3 is 3. We're left with 36 over 3. Well, 36 over 3, that simplifies to 12. So we're left with k equals 12, and that's our final answer for that question. Hopefully this was essentially a crash course of what you guys need to know for solving one-step equations, but at the same time, this is how you move these operations to the other side of the equal sign to move them away from your variable. So just remember, inverse operations are operations that undo each other. They cancel out. So essentially, as far as one-step equations, this is it. This is all we're going to talk about. So now most of our focus, we're going to spend on multi-step equations. So this was it. This was your 5-minute crash course on remembering how to solve equations, getting the letter by itself. And again, if you need more help and more detail on these, please check out some of they were chapter 3 videos from last year of solving equations. There's specifically a video on solving rational coefficients. There's specifically a video that's the overview of solving equations. That was a really good, helpful one for a lot of people. And there is even a video on how to solve equations with variables on both sides. But we're also going to end up doing another one kind of our own for Algebra 1, where we'll just kind of briefly review it and practice it. So now we're going to focus on multi-step equations. Alright, so remember, when solving multi-step equations, you solve them by working backwards. And I literally mean that as if we were talking about PEMDAS, the order of operations. You're going to undo the order of operations, but you can go in reverse order. And we've already know how to undo things now from we kind of crash course in the last part. But now we're talking about what order to do it in. So you know the how. Now we're going to talk about the when. For example, if we had 8x minus 5 equals negative 21. And by the way, as a side note, in each of these questions, you may have decimals, fractions, negatives, but that means those tools in your toolbox, you have to make sure that they stay clean, you're ready and fresh, you know how to use them. So in this case, we got to get rid of times 8, and we have to get rid of minus 5. Now, many of you guys already had a habit or used to this from last year, but just to be clear, order of operations. Subtraction comes later in the order of our operations than multiplication. So for that reason, it's the first thing we undo. It's the first thing we're going to move to the other side. So we're going to move that minus 5 to the other side by adding 5. Cancel on the left, we're left with 8x. This is still left on the left side. Now on the right side, negative 21 plus 5. This is where I mentioned your negative skills. It means you're coming back towards 0, so that's going to be negative 16. And now our final step is to get rid of times 8. Get rid of times 8 by dividing both sides by 8. We're left with x equals negative divided by positive is a negative, negative 2. That's going to be our final answer to this question. And that's what I mean by multi-steps. There's multiple steps for you to undo and solve. This next example, I don't think we spent too much time doing these types in the past, but they are within our abilities. So let's apply what you know and hit pause for the next one and see if you can do it yourself. So try this example on your own first. Hit pause and see if you recall how to do it, and imagine order of operations in reverse. Okay, so in order to understand how to do this one, think about it this way. We would have to do this entire, if let's say we knew what n was, we would have to do that entire top before we would then divide by negative 2. Well, that implies the last thing you would have done is divide by negative 2. So because of that, that's the first thing you undo, because remember, we're working backwards. So the first thing we're going to do is we're going to undo that. So we're going to multiply both sides by negative 2. That's a really big multiplication symbol. Let's use a dot so it's more clear. We're going to multiply negative 2 on both sides. And now they cancel on the left side, and we're left with just n plus 3. And on the right side, 14 times negative 2, positive times negative, well, that's negative 28. Now we're left with a one-step equation. And by the way, hopefully this statement rings a bell. What we now have, this is a vocabulary moment, this is called an equivalent equation. It's equivalent to the first one for 2 reasons. One, it has the exact same solution as the original version. That's the first reason. And 2, it's an equivalent equation because we found it by following the properties of equality. In this case, we multiply both sides by negative 2. So n plus 3 equals negative 20 is equivalent to the original. Just like in our last example, 8x equals negative 16, that is an equivalent equation to the original starting equation. So that's vocabulary moment. Make sure you understand how to recognize those. Anyways, let's finish this question up. Gotta get rid of plus 3 by subtracting 3 on both sides. Cancel on the left. You're going deeper into the negative, so we're going to be at negative 31. And that's going to be our final answer for this example. Now, what I thought was different that you may not have remembered from, that we may have specifically talked about in the past, was what to do if you have a denominator down here. I don't know why I circled the whole thing. If you have a denominator down here, you have to get rid of first. And I just want you to realize, to get rid of a denominator, in order to get to your variable in the numerator, you multiply it to the other side. That's what you'll always do to get rid of a denominator. One more thing before I move on, I want to point out, you guys may notice in a lot of these videos and on the board, I tend to like to use different colors for things, and I want you to realize the reason why. It helps you stay organized. As a brief note, this might be something you might want to do in your notes or on your practice assignments, is when you have your original statement that can be in just a standard color, black, pencil, whatever. But when you're doing something to both sides, for example, those +5s and the slash, that wasn't already there. Me showing my work of what I did to both sides, I'm doing it in other colors so you know what was originally there and what did I add. So this color coding can help you stay organized a lot. That way when you look at something like this, you don't think it was already over 8 over here or over here. You're just thinking it's the 8x equals -16, and what I did is divided both sides by 8. That was my work. That was my step. So a lot of times the color coding can help allow you to stay organized. I know some of you have been trying to think of ways to get better organized. You don't have to color code everything, but maybe just your work that you do to both sides. Maybe use a different color pencil, or maybe if you know you're doing it correctly and you're verifying your notes, you can always do it in like a colored pen. That's fine, as long as you're neat and organized, not making mistakes. But be sure you know you're doing it correctly before you use pen. Alright, so for these next few examples, after I write them, I want you to press pause. I want you to try them. You try, actually hit pause and try them, and hit play and see how you did. Alright, so these are the ones I want you to try, and now I realize one on the right's got lots of fractions, so maybe do it on another sheet of paper or take your time and write it lightly with a pencil. But let's go step by step, and I want you to answer each of these. Press pause and give them a shot. Alright, so make sure you hit pause and you try each of these. Alright, so I'm going to start by showing you the answers to them. And so now, if you're not sure where that answer came from, you want to make sure that you watch that part of explaining how to do it. But if you definitely got these correct answers, you didn't have any doubt, and you're not assuming, actually try it. You need to make sure you can get them. And if you can't, make sure you pay attention. And your note should have you showing the work of how to do it. Now the next two slides, I'm going to show how to do each of these. But like I said, if you already have the answers, you can just fast forward. Just make sure your notes make sense and your steps are acceptable. Otherwise, feel free to do it how I'm doing it. Alright, so I'll start with the easier of the two. So we have divided by -2. That's the first thing we get rid of because it is the thing that is furthest away from our variable. Our variable is in the numerator, so you have to get rid of the denominator before we can do anything else. Okay, so to get rid of divided by -2, we do the opposite. So we're going to multiply by -2. And we have to do it on both sides. There's different ways to write how to multiply by -2, but essentially just make sure you indicate that's what you're doing. Cancel on the right side. So on the right side, we're left with 6 plus z. On the left side, 14 times -2. Well, 14 times -2, that's -28. Now we just have to get rid of plus 6. So to get rid of plus 6, we subtract 6 from both sides. And by the way, if you didn't realize this was plus 6, another way to explain this is this. There's nothing in front of the 6 right here, so it's positive 6. And you can just ask yourself, how do you move an entire term? Meaning, this is a term, this is a term. How do you move an entire, you know it's a term by the way because it's separated by addition or subtraction. You move an entire term always by either adding or subtracting. And it's the opposite of whatever it currently is. This is currently nothing in front. So this is currently positive 6. So the opposite of positive 6 is -6. Another way of saying that's why we're subtracting 6 on both sides. So I just want to point that out if that helps you understand a little bit better that way. Alright, on the right side we're left with just z. Now on the left side, -28 minus 6. We're going further into the negatives, so it's going to be -34. So our final answer is z equals -34. But those are the steps of how we got there and the rationale of explaining why. So make sure you understand how to do that one. And now I'm going to work out the second one, but if you already know how, you're welcome to hit fast forward and just make sure you have the right answer with the proper steps shown. Now, I'm going to make sure that I show my work for all of this. That way there's no doubt on how we did some of it. So some of the fraction operations I might do off on the side reminding you how to do it, but we're going to go through and do it this way. Alright, so to solve for z, we have a multiplying part and we have an adding part. So the first one to get rid of is the adding part. So we're going to subtract half from both sides. So they cancel on the right side. So now on the right side, we're left with 3/4 times z. Now on the left side, you just have to figure out what is -5/2 minus 1/2. Fortunately, we already have common denominators, so we don't need to do that. So we just have -5/2 minus 1/2. So essentially, the denominator is going to stay the same when you subtract fractions, so we just have to worry about the numerators. We have -5 minus 1. Well, that's -6. So we have -6/2 equals 3/4 z. I agree, you know what -6/2 simplifies to. You're going to say, we'll just make that -3. And sometimes that is the best call. But since this is a fraction question, I'm going to go ahead and just leave it. I'm just going to rewrite it as -3/1 or -3. So you can either change it now or you might want to change it later. You usually base your decision off of what's left in the question. I see we have a fraction left. In order to do operations with fractions, you need both of them to be a fraction. So even if you put it over 1, that's perfectly fine. So I'm going to leave it that way already, but you're welcome to make it -3 as of now if you want to. All right, anyways, we're getting rid of times a fraction, so we divide both sides by that fraction. And now right below it, actually I'm gonna work it out on the side over here. We already said that -6/2 is the same thing as -3/1, or just -3. So now we're going to show our work of how to do divided by 3/4. Notice I'm not going to write it down here because I want to make sure we can fit all of it. Okay, so didn't mean to erase that. So -3/1. Now I'm going to work that out. Okay, so you know with -12/3, and that simplifies to -4. So that means we're left with z equals -4. That's how we get the final answer. And I showed the work for this portion right here. I showed that over here. And sometimes you can do something off on the side to clear up space so it doesn't make it look too intimidating or too hard. And this is make sure you understand how to do these. Okay, so the last thing we're going to talk about, and the video is going to be all done, we're going to talk about consecutive integers. Consecutive meaning they one after the other. Integers meaning positive or negative whole numbers. Okay, so consecutive integers are integers that are in counting order, such as 4, 5, 6. It also can be known as n, meaning like 4, n plus 1, 4 plus 1, well hey that's 5, or n plus 2, and so, because that's the 4 plus 2 to give us 6. So in other words, you're just adding an increasing amount each time to the original number. In this case, the original number was 4, or we just call it n to be generic. These are consecutive integers. As a side note, what we're doing, we're actually talking about number theory right now. And number theory is the study of numbers and the relationships between them. So that's kind of what we're talking about. We're talking about consecutive integers. So what we're going to do is we're going to do a couple questions using consecutive integers, and then we're going to do some examples, and that's it. The video will be over. As a side note, we also have consecutive even integers. Consecutive even integers are if you start with an even number, such as, let's say, 4, and then you add 2, you'll have 6. Then add 4, you'll have 8. And you'll add 6, and you'll have 10. But essentially, look what you're doing. You have consecutive even numbers, 4, 6, 8, 10. Those are even numbers in order. That's what we mean by consecutive even integers. You can have the exact same thing for odd numbers, but for odd numbers, it'll look just like this, but the first number must be an odd number, because an odd number plus 2, plus 4, plus 6 will always equal another odd number. So you have both. So consecutive odd integers are just like consecutive even integers. They use this format, they're what's in red, but they just start with an odd number. So an example of what I mean by a consecutive integer problem, a lot of time when we see questions like this, we think they're a guess and check question, and they can be, but there actually is an organized way to mathematically set it up and solve it. For example, let's read this question. Find 4 consecutive integers that have a sum of 44. And remember, sum means to add. So we're talking about an addition problem. So we're asking for 4 numbers that are in order that add up to 54. So numbers like 26 plus 27 plus 28 plus 29. We're asking for 4 of them in order to add up to 54. Now the ones I chose are obviously way too big. So guessing and checking would be like, okay, those are way too big, we gotta go a lot smaller. But I'm going to show you there's an organized way to set this up. And here's what it is. Let's use what we just talked about for consecutive integers. The first number is just the number n. We don't know what number it is yet. But to add to that, we're going to add the second number. The second number is n plus 1. So let's say this was 5. Well, this is 5 plus 1, so that's 6. So we're going to have 5 plus 6. And so we're going in order, so we just keep going. So for the next one, we're going to do n plus 2. Again, if this was 5, that would make this one 7. So we're going 5, 6, 7. So we're going in order. So we're just going to do it one more time. Plus n plus 3. Now, technically, because this is addition, we don't need the parentheses, the associative property, and the commutative property. We can use in any order we want because it's all addition. But I was just doing it to kind of show you that they are standalone units. So let's say the answer was 5. This could be plus 5, plus 6, plus 7, plus 8. This is how you could represent them because that's 5 plus 3. That makes 8. This is how we can write it as a consecutive integer problem. And we said that all these will add up to 54. So all that's going to equal 54. Well, look. We now have an equation. All we've got to do is combine like terms, and like I said, these parentheses, we don't even need them because of the addition, the associative and commutative properties of addition. So we just combine like terms and then get n by itself. We're all done. So let's solve this one down. We have 1, 2, 3, We have 4 n's. So altogether, we have 4 times n. We have plus 1, plus 2, plus 3. Those are like terms. 1 plus 2 is 3. 3 plus 3 is 6. So we have 4n plus 6. We still have equals 54. So we really now just have a two-step equation that we need to solve, and that's what we're going to do. So this is the equation that we're going to solve. Solve all the way down to you get n by itself, with n equals 12. That means n is 12, which means our next number was 12 plus 1 was 13. So 12, 13, 14, and 15. Those are going to be our consecutive numbers that add up to 54. But let's double check just to make sure. They do add up to 54, so it checks out. So those are our 4 consecutive integers that add up to 54. So I want you to see, these aren't necessarily guess and check problems. We're going to do one more that I want you to try. Hit pause and try on your own, and then hit play and make sure you have the correct answer, the correct steps, and then we're all done. Alright, so I want you to try this one. It says to find 3 consecutive even integers with the sum of negative 84. And as a reminder, if we have even integers, that remember, you're going to add 2 for the next one, add 4 for the next one, add 6 for the next one. For even or even odd, it has the same format. So I want you to use that to help you answer this question. Just make sure it adds up to negative 84. Press pause, give this one a shot. If you're having trouble setting this one up, it'll look like this. So if you haven't done it yet, do so now. Press pause. Okay, so I'm going to start by combining like terms. It's addition, so the associative and commutative property of addition tells us we don't really need these parentheses. So n plus n plus n, well that's 3n. 2 plus 4, well that's 6, we have plus 6. We have 3n plus 6 equals negative 84. So now this is the two-step equation that you're now going to solve to answer this question. That's what you're going to do. Subtract 6, they cancel. You're left with 3n equals negative 84 minus 6. That means you're going deeper into the negatives, so that's going to be negative 90. Now to get rid of all coefficients, we divide. We're left with n equals negative 30. So that tells us our first one, n, is negative 30. That's what that tells us. Now, when we say consecutive, when we're talking about negative numbers, in this case, negative 30 is our first one. But our next one is going to be not negative 32, it's going to be negative 28. Consecutive meaning getting larger, and going in order from least to greatest. So the next one is negative 28. And that means the next one is negative 26. So those are our numbers that are going to add up. And feel free to test those. Add those together, and if you do, you'll notice they do equal negative 84. So the 3 numbers that answer this question are negative 30, negative 28, negative 26. This is an example of consecutive even integer problem. So hope you have down the notes for all of these. So make sure you come to class with organized set in mind. And again, if you need more help understanding how to solve equations in general, please, I will link you to them. Check out some of the videos from last year when we were talking about how to solve equations, where we did a lot more examples of them as well, with a little more explanation. But other than that, come to class. We'll take this to the next level. Take care.